Yes, guys, good morning. Welcome to our today's class. Hope you had a nice weekend. And today it's Monday. We are going to move forward, right? And you need to know that next week we are going to be done with CCNA1, right? And as you know, most of the practicals you already finalized with them. And from next week, we are going again to do maybe 1 or 2 practicals, right? Beside that, you need also to understand that we are doing chapter 8 to chapter 10, and you're going to write your exam. That will have maybe those 3 chapters, chapter 8, 9, and 10, right? So today we are going to do chapter 8, tomorrow chapter 9. We won't gonna do chapter 10 because chapter 10 talks about routers. And when you go to your Neta card, to your platform, you are going to notice that most of the stuff, we covered them already. So we already covered chapter 10, right? So we can only do chapter 8 and chapter 9, right? So if you don't understand, so I said we weren't gonna do chapter 10 because we did most of the stuff there. You can go to your platform, to your course, you will notice that most of the stuff we covered them already. So today it's chapter 8, tomorrow chapter 9, and after tomorrow we are going to decide when we are going to write our exam. So that next week, Monday, we are going to move to chapter 11, all right? Yes, and you have to use your time to do the practice questions, right? So when you are free this week from 12, maybe you have to start practicing, especially those who don't have maybe computers or maybe you're struggling with data. Please, you have to start practicing, right? Morning. Yes, let me try to share my screen. Yes. What must I do? Okay, let me try to see if I can. Yes. Network layer. All right, we're going to talk about network layer. As you know, we spoke about the OSI model. That model has 7 layers, all right? And those layers, there is layer 1, layer 2, layer 3, and so on. Network layer, we're talking about layer 3, all right? And from network layer, our mind must go to IP address. IP address and routing. So when we are talking about network layer, we have to think about default gateway, IP address, routing, all right? And when we're talking about layer 2, data link layer, we're talking about MAC address, all right? But from the network layer, your mind, your idea must go to default gateway, routing, routers, and IP address, all right? Yes, so those are the things that we are going to learn, all right? Number 1, we are going to explain how network layer use IP protocols for reliable communications, explain the role of the major header field in the IPv4 packet, explain the role of the major header field in the IPv6 packet, explain how network devices use routing table to direct packet to a destination network. And the last one, we are going to explain the function of field in routing table of a router, right? So those are the things that we are going to cover, the objective at the end of these lessons, right? Now, first, let's discuss about some characteristics of a network layer. What are the characteristics of a network layer, right? So number 1, you have to understand that when we are talking about network layer will provide services to allow devices to exchange data. Your PC needs to talk to another PC. So the network layer will provide the services that will allow those two PCs to exchange data. All right, you got your phone, you want to talk to another phone. The network layer will provide services that will allow those two devices to talk. Right? And you have to understand this. We are going to use IP version 4 and IP version 6, right? So in network layer, we are going to use two IPs, IP version 4 and IP version 6. Now, we do have 4 basic operations, right, that the network layer can perform. So as I said, there are 4 basic operations that your network layer can do, right, from the OSI model. That network layer can perform 4 basic operations, right? Your network layer will do first what? What we call addressing, right? What does it mean? From the network layer, you are going to assign your devices IP addresses. And from those IP addresses, your device can communicate, right? So your network layer will make sure that your devices will get those IPs and they can share between themselves. So they can talk using those IP addresses. So operation number 1, making sure that the device can get those IPs and they can use those IPs to reach each other, right? Number 2, among the operation, we're talking about encapsulation. Number 2 is encapsulation, right? What does it mean by encapsulation? I told you last time, encapsulation means, you see when you want to send to somebody like a letter, right? You can take your letter, you put it like inside an envelope, right? You see when a message will come from the transport layer, you remember that the transport layer is layer 4, that is above the network layer. When a message will come from the transport layer, right, your message will do what? Your message need to reach the network layer. So the network layer will do what? Will do the encapsulation, right? Encapsulation means the network layer will add some IP header, some information related to IPs, right? So when I have my message, when my message will reach the network layer will add what? Some information related to IP. So we call those information IP header. Because of that information, I will know how to reach a particular computer. So the encapsulation means when data will reach the network layer will add some information related to IPs, right? And beside that, the third operation is what we call routing, right? Routing, you know, we spoke about it last week when we were talking about routing. We're talking about a process of sending data, right? So a process of sending a packet, right? So when we're talking about routing, we're talking about a process from sending data from one router to another router, right? So this is routing. How to send data from one router to another router, from one network to another network, right? So, and you have to know that when your message or your packet will reach or maybe will cross one router, we call it a hop. When I'm going to reach the second router, it means 2 hops. When I'm going to reach the third router, it means 3 hops, right? So when a packet will cross a router, we call it a hop, 1 hop. When I will cross the second one, it's called the second hop, right? And the last one is the encapsulation. When you receive a letter, what you must do, you have to open the envelope in order for you to understand what is inside the envelope. right? So your message will be encapsulated by the network layer. Means the network layer will precise some information related to IP. And when I'm going to receive that message or that packet, so I have to de-encapsulate. So I have to remove the IP header, right? So this is what does it mean, right? So those are the 4 basic operations. Number 1, making sure that devices can talk using IP addresses, right? Number 2, making sure that the IP header will be added to your data. So making sure that some information related to IP will be added to your message. Number 3, making sure that data can move from one router to another router. We call it routing, or from one network to another network. And number 4, making sure that the destination router can do what? Can de-encapsulate, right? This is the meaning, this is what the network layer does, right? The easiest way means first operation, making sure that devices can communicate or can locate each other using IP addresses. Number 2, making sure that when you got your message, right? You don't know where your message will go. You need some information, right? And the network layer will add those informations. We call it IP header. And that process of adding a new information, we call it encapsulation. Number 3, it's routing. So the network layer will make sure that networks can talk, networks can communicate, right? And number 4, it's the encapsulation, right? So when the receiving host will receive the message, that host needs to understand the meaning by removing the message like inside the envelope, right? This is what does it mean. We can move to the next slide, right? So this next slide will explain again about the IP encapsulation, right? So the IP encapsulation means that you are going to have your message. So as I said, your message will come from the transport layer, and your network layer will do what? Will add some information, right? So you can see here, there is this the segment header and data, right? So when data will move from the transport layer to the network layer will add what? Will add an IP header, right? And this is your message. This is some information related to where to send your data, how to send it, what are the protocols we have to use. This is the meaning, right? And IP can use either IP version 4, IP version 6 packet, and not impact the layer 4 segment. So from the network layer, you can use version 4 or version 6 when it comes to IP, right? And you have to understand again that the IP packet will be examined by layer 2 devices and traverses the network, right? So what does it mean? Every message, so every packet that you are going to send from one location to another location, when that message will reach a router, the router needs to understand the meaning, right? This is the meaning of examining. When the message will reach the router needs to understand the meaning of that message, where to send the message, right? So, and the last one, somebody's trying to call me. So the IP addressing does not change from source to destination, right? So it means this: you got 2 computers, right? The sender and the receiver, right? No matter how far you are, no matter how many devices are in the middle between you and your friend's computer, the IPs will never change. right? The IP that the source will use and the IP of the destination will never change, right? The MAC address will change. Sometimes it can get like another MAC address from a particular device or from the router and so on. So the IP will never change, right? So you can be like in Durban, I can be in Pretoria. When I'm looking your computer, the IP that I'm requesting, the IP that I'm sending will never change, right? So we can move to another slide. So from this slide, this one, what does it mean, right? It means that when your message will be from the transport layer, right? And your message will reach the network layer, right? You have to precise some information related to your packet, related to your message, how to send your message, where to send your message, what are the protocols that you have to use. So all those informations, they are inside what we call the IP header, right? So don't be mad. So IP header means like a set of information that will precise where to send your data, how to send it, which protocol to use, right? So you're gonna have one side your message and one side the IP header. So the IP header will have all those information related on how to send this data. This is what we're talking about, right? So we are talking about, so I know that those concepts, they be tricky. We're talking about this. You have your message here, you have the IP header, right? Your message doesn't know where to go, which network to reach, which protocol to use, which IP version to use. But this IP header will come with all those information, right? In order to send this data properly. So those two will be combined, right? And the IP packet will be examined by all layer 3 devices and it travels to the two. So it means this, when you have two devices, those two devices want to talk. Between them, there are so many routers, right? For your message to reach your friend's messages. But for your message to reach your friends' PC or phones, there are so many routers like in the middle, right? So when your message will reach one router, we call it one hop, right? And that router needs to examine the content of that message. So that router will check the IP header, where this message is going, which protocol to use, right? This is the meaning of examining, right? And when they are saying that the IP address does not change from source to destination. So when I'm sending you a message, my IP, your IP that I want to reach will never change, right? Okay, we can move now to the next slide. The next slide talks about the characteristics of IP, right? So IP is meant to have low overhead and may be described as, right? So IP is very fast. When you are using this IP, it's very fast, so it doesn't require a complex operations, right? So IP, when you are using your IP version 4, means that the main responsibilities of this protocol will be to locate networks, locate devices, not like tracking, managing them. Sorry, right? So the IP won't wanna look at tracking, troubleshooting, maintaining, managing. No, the only things that this IP will do is how to locate networks and devices. Finished, right? And among the characteristics of your IP, you have to understand that this IP, sorry, Yanga, what's happened? You have to understand that your IP is what we call connectionless. Among the characteristics of IP, number one, IP is connectionless. What does it mean? We have to know this concept. For two devices to locate each other using the IP address, there is no need for them to establish the communication, right? So it's like when you're gonna get married, there is no need for you to have a common agreement. So you just come and pay your lobola straight. This is the meaning, right? So connectionless means that there is no common agreement first before those two devices to start talking, right? So there is no established of a connection, right? So for two devices to start talking, right, or to start exchanging data, there is no need for a road to be open, right? Because for other protocols, the road must be first open, virtual road must be open, and now we can start talking. But with IP, we don't need that road to be open. We can just start talking. This is number one. So for me to marry you, so I won't gonna wait for you to agree. I can just, right? Number two, it's best effort. One of the characteristics of IP is best effort. What does it mean? It means when you are using your IP address, especially version 4, it's unreliable. It's not guaranteed. What does it mean? It means that when I'm sending you a message using an IP address, there is no way for me to be sure that you received that message. This is the meaning of unreliable or not guaranteed, right? There is no way I can be sure that you received like a message, right? So normally when you receive something like a message, the sender must have a message that will show like your destination message reached the destination, right? But with IP, it's best effort means unreliable or not guaranteed. It means when I'm sending you a message, there's no way I can check if you receive it or not, right? There's no guarantee. Number three, it's media independent. Media independent means it doesn't depend on the medium. So your network can use fiber optics, we can still talk. Your network can use a copper, we can still talk, right? So it's independent. So it doesn't depend on a particular medium. This is the meaning, right? So if I want to summarize, you have to understand this. Number one, your IP is connectionless, means there is no need for us to have a common agreement before sending, before starting communicating. Number two, there is no guarantee that you are going to receive my message. And number three, it doesn't depend on the type of cable we are using, maybe it's Wi-Fi, so it doesn't care. Data will still flow, all right? Let's move to the next slide. Okay, this slide will go like back again, try to re-explain again what we already spoke about. Number one, we're talking about a connectionless. What does it mean? IP does not establish a connection with the destination before sending the packet. So as I told you, number two, there is no control information needed, synchronization or acknowledgement. So from number two means there is no need for synchronization and there is no need for acknowledgement. So acknowledgement means that, like when I'm sending you like a message, you must send me a feedback that shows like you received it. This is the acknowledgement, right? Number three, the destination will receive the packet when it arrives, but no pre-notification are sent by IP. So as I said, I can send you a packet or a message. There is no notification, all right? And number four, if there is a need for connection oriented traffic, then another protocol will handle this, right? So suppose like you want to connect devices, but you wanna make sure that data will reach the destination. You wanna have a feedback, right, from the destination devices. Now you have to choose another protocol beside this IP, right? This is what does it means. Okay, now we're talking about best effort. We say that among the characteristics of your IP is best effort. What does it mean? Number one, IP will not guarantee delivery of the packet. There is no guarantee when you deliver your packet. Number two, IP has reduced overhead since there is no mechanism to resend data that is not received. IP will be very fast. Why? Because there is no sending back, there is no feedback, right? Because when you are waiting for a feedback, your network will be slow. Now, there is no feedback, you can just start, okay, I can send you something without even receiving the feedback, right? That's why this type of network, it's very fast. Number three, IP does not expect acknowledgement. What does it mean? IP will never wait for a feedback. Acknowledgement means feedback from the receiver, right? So when I'm sending something, you will send an acknowledgement. You recognize that you received something from me. But with IP, there is not this acknowledgement, right? Number four, IP does not know if the other device is operational or if it received the packet. What does it mean? Maybe I'm trying to talk to you, so I'm trying to send to you something, or maybe I'm trying to reach the server. Sometimes maybe the server is down, right? So there is no way I can know that the server is down. My message will still go, right? This is what does it mean. We spoke again about reliable. We say that the IP is unreliable. What does it mean, right? Number one, it cannot manage or fix undelivered or corrupt packets, right? So if we are trying to talk, so if there is a mistake or error or a problem, your IP will never fix it. Suppose like I want to send you a corrupt message, right? IP will never fix that, right? So for a corrupt message, IP doesn't have like any mechanism to fix the problem. Number two, IP cannot retransmit after an error. What does it mean? Suppose like I want to talk to you and maybe there's a power cut or there's a problem, right? It means that my message will have a problem. They're going to be like error message. There is no way your IP can resend that corrupt message or that error. So when I'm trying to talk to you, if there's a problem, there's no way to resend it back. Number three is IP cannot realign out of sequence packet. Right? So what does it mean? So when I'm sending to you a message, when a computer like a PC is trying to send another message to another PC, right? That message will be split in different packets, right? That message will be split in different packets, right? And for those packets, they are going to have a number, like a sequence number, right? When you are going to receive those packets, those sequence numbers, you have to put them like in order, right? You have to realign them in order for you to understand the meaning, right? And this IP cannot do that, right? You know, when you're sending a message, you're typing and so on, right? You're typing a long message. Your message doesn't travel like that, like the whole, like one box. No, your message will be divided in different parts, right? And for different part, there's a specific number that we call a sequence number. And when you're gonna send those smaller packets to your destination also will receive those smaller one, but it needs now to make it again one in order for that destination to understand the meaning, right? So number 4, IP must rely on the protocols for these functions. So there are some other protocols that IP needs to rely on, right? So for this chapter, you're only learning like the theory, just trying to understand how those protocols work. IP is media independence. IP does not concern itself the type of frame required at the data link layer or the media type at the physical layer. So IP can be sent like over any media type, like copper, fiber, or wireless. To talk about this, right? Fragmentation is when layer 3 splits the IPv4 packet into smaller units. So what does it mean by fragmentation? You remember from the OSI model, layer 4 is the transport layer, right? From the transport layer, you have to fragment your message, right? When you fragment your message, you're gonna make it like smaller one, right? We call it segment, right? And that fragmentation will cause what we call latency. Latency means delay, right? So delay of sending, when you are sending or when you are receiving, right? But when you're using IP version 6, there is no fragmentation. So the fragmentation is happened from IP version 4. As I said, fragmentation means you're splitting data in different smaller units, right? And when you're going to split those smaller units, you have to send your segment to the network layer, right? And that process of splitting your message will cause a problem, like delay. We call it latency, right? The delay when it comes to receive or to send data. And you have to know that for IP version 6, there is no fragmentation, right? Okay. 8.2, we're going to talk about IPv4 packet, right? As you know, you got your message, you're typing your message, you have to send your email, but that email must know where to go, how to go, how to reach there, right? And those informations is under what? IP header, right? Now, let's see how that IPv4 packet looks like, right? Because when you know you have some information on how to send your data, and you have your data here, you create what we call IPv4 packet. Now, what is the format or how that IPv4 packet will look like, right? You don't need to know to configure, just learning just few things just to understand. Yes. Number 1, you have to understand that IPv4 is the primary communication protocol for the network layer, right? And when we are talking about the network header, we have to understand why we need this network header. Number 1, it ensures the packet is sent to the correct destination. So I have your message, I need what we call an IP header. That IP header will allow me to send data to the correct destinations, because that IP header will have the information related to the destination computer. Number 2, it contains information for network layer processing in various fields. And number 3, the information in the header is used by all layer 3 devices that handle the packets. All right? Okay. This is how the network layer, the IPv4 packet header field looks like, all right? So when you're typing your message, you are fine, or maybe when you're sending a picture, you are happy. But that picture, right, your picture, this is the data, must be combined with some information related to how to send it, where to send it, right? This is called the IP header. When you combine it, we got what we call IPv4 packet header field, right? Let's just see how it looks like, right? So the IPv4 network header characteristic, number 1, it is in binary, right? And number 2, it contains several fields of information. So that packet header will have different parts, right? those part we call the header, right? Or the field. And number 3, diagram is read from left to right, 4 bytes a line. So this diagram here, for you to read it, you can start from left to right, from the versions, like internet header length, up to total length. And number 4, the 2 most important fields are what? There's the source and there's the destination. So in summary, I was saying this, you have to understand this. There is what we call IPv4 packet header, right? What does it mean? It means this. When I have my data, so I need to add some information related to how to send data, where to send it, right? So now when you combine your data plus your IP header, we got what we call IPv4 packet, right? So when you are typing a message, when you want to send it, that message, that packet needs to be combined with some information related on how to send it. We call it the IP header, right? But logically, how does it look? So it looks like this table there. It's like a table, like a diagram, like this diagram, right? This diagram just show you how that message looks like and what are the fields, right? So, and you have to know that from this diagram, the most important it was source IP address and destination IP address. What does it mean? You got your data, right? You got your IP header, right? When you combine them, means that inside them, you are going to have source IP and destination IP, right? And those are the most important fields, right? Which device is sending and which device is going to receive. That message needs to go together with your packet. There's no magic when you are sending data from one computer to another computer. So it means what? It means that when you are typing a message, that message will have some information related to the computer that is sending and the destination that's going to receive. So the IPs, right? Now, those are the fields. They are trying just to explain those fields, right? Those fields, like in general. The first one is what we call the versions. So the version will explain maybe if it's version 4 that you are going to use or version 6, right? And it's what we call differentiated services. You're going to use it for what? For quality of service. And there is the header checksum that will allow to detect the corruption in the IPv4 header when there's a problem or error. That field will detect it. There's what we call a time to leave. So time to leave means when it becomes 0, the router will discard the packet, right? So time to leave, we saw this concept already. Means this, how long I have to wait before deleting a particular message. And the protocol, which protocol you are using, and there's the source IPv4 and the destination IPv4, right? As I said, there is no need for you to memorize like so many things. There is no need for you to try to understand like deeper, what does it mean? You have just to understand this shortly. When I have my message, maybe I want to send a picture to my friend. That picture needs to know where to go, who's going to receive it, right? How to receive it, when there is a problem, what to do, right? So that picture, you are going to add some other information related to how to send it, how to detect if there is a problem, which IP like to use, version 4, version 4, version 4, version 6. So you combine your picture plus all those informations. Now those informations, we call it what? IP header. IP header plus data, you send it, right? So when you combine your IP header and your data, you create what we call the packet header, right? Now that packet header will be divided in different parts. Those parts we call them field, right? And for every field, there's a meaning, right? There's a field like versions that will precise which IPv version to use, version 4 or version 6. There's a header, a checksum, how we detect when there is a problem. There's a protocol, which protocol to use, what's going to be the source, what's going to be the destination. This is just what that says means. So there's no magic when you can see like devices can talk, like messages will come from one device to another device. It means for every message, there are going to be some IP headers that will determine how to send it, where to send it, how to detect when there's a problem, and so on. Right? So that message will be divided in different small parts. We call those part fields. And for every field, there's a specific need and functionalities. Right? Now we're going to talk about IP version 6. Right, let me see if I can give you a break, or maybe you can just carry on. All right, I'm just checking if. Okay, I think we can just carry on with IP version 6, right? Okay. Or maybe I can give you like a break, and later on we can continue with IP version 6, right? So you can have a break now, and we can move to IP version 6 packet, right?